Okay, so with related rates, hopefully you remember FWIGI. What does the F stand for in FWIGI? Find. Okay, you got to identify what are you looking for. What's W? When. What's the G? Given. And the E? Equation. Okay, equations you should know. Area of a circle. Circumference of a circle. Pythagorean theorem. You could write that as a squared plus b squared equals c squared. Okay, there are others like you should know how to do area of a triangle. And these are kind of the most common ones. The sphere and cone type stuff, those are given to you, okay? Or they have been so far. All right, so this is, by the way, not on your yellow card. I did not put it on there. If you already remembered it, you don't need it on your yellow card. But if you're like, oh, I got to study that, then put it on your yellow card. Okay, turn the page, and I want you to look at number 1. We're not going to actually do this one together, but I want to at least look at it. Okay, the reason this is in the related rates packet is because this says the rate at which something is increasing. Okay, we don't really need to do FWIGI though on this problem. This is really just a plain old derivative problem. Okay, rate of change, that's derivative. Okay, so when you look at this problem, just approach it as this is just a derivative problem. Okay, let's all look at 2 together. We're going to do this one together. So it says the radius r of a sphere is increasing at a rate of 0.3 inches per second at the instance when the surface area S becomes 100 pi square inches. What is the rate of increase in cubic inches? Okay, so that's a lot of information. So we do FWIGI so that we can kind of break it down. Okay, so first of all, what are they asking us to find? Of what? Of volume. So we write that as dV over dt. The d, the rate of increase, is the d part. It stands for derivative. Okay, when what? When surface area is 100 pi square inches, and we could use units here since it's multiple choice. You don't really have to list that out. Okay, what else is given? Yeah, what's 0.3?
dr over dt.
Yeah, and what does r stand for?
The radius.
The radius. And I'm just kind of saying this because I know this is a point where it's easy to get mixed up. A lot of people start thinking R stands for rate. It doesn't. What letter do we use for rate? D, because D stands for derivative. And that's what a rate is, okay? So, our equation. Now, I get that they gave us 2 equations. And by the way, I didn't draw a picture here because drawing a picture isn't really going to help us. But on another problem, maybe drawing a picture would help. So, which equation are we actually going to derive? S or V? Why? Trying to find dV over dt. So the equation I'm going to put here, now the other equation is going to be important, but this equation right here is what I'm going to actually derive. Okay? So I'm going to take the derivative of both sides with respect to t. So that gives me a dV over dt on the left. And then when I derive the right-hand side, 3 times 4/3, 12/3 or 4, you could write it either way, pi r squared times dr over dt. This is like implicit differentiation. Anytime you take derivative of a letter, you got to go d, that letter, over dt. Okay, so now let's plug in what we know. Okay, we're looking for dV over dt. So I'm going to put excuse me, 4 pi. Ooh, I don't know r squared, but I know dr. Okay, so let's think about this. I don't know r, but I have some information that I have not yet used. When you're like, oh, I didn't get this, go back and look at the information that they gave you that you haven't used yet. They told us that S is 100 pi and that S is 4 pi r squared. So what could I do with that? Set them equal to each other. They're both equal to s, so set them equal to each other. And this is a non-calculator problem, so you got to be able to divide by this 4 pi. The pi's are going to cancel, so what is r squared? 25. Okay, and that's what goes here, because it is r squared. You could have solved for r, gotten that r is actually just 5, and then squared it again. That would be kind of pointless. All right, so 4 times 25, that's 100. 100 times 0.3 is 30. So 30 pi e is my answer. So this problem is not super difficult. Yeah, we had the little hiccup over here, but you guys can do these types of problems. We just need to practice a little bit. All right, I'm going to now work on a much harder one. Okay? So we went from easier, easy medium, to probably the hardest problem on the packet. Okay, and I'm going to explain to you how you get points on this. Because I know some of you are sitting here thinking, I'm never going to get all the points, so just like I'll skip this one. Okay, that's like not a good strategy. All right, so first of all, let's read the problem and make sure we understand what's going on. As shown in the figure above, water is draining from a conical tank and it's dripping down into, and this conical tank has a height of 12 and a diameter of 8. All right, and then the cylindrical base is 400 pi square feet. The depth, h in feet of the water in the conical tank is changing with a rate of h minus 12 feet per minute. So we have two shapes going on. And again, you might just want to quit. But here's the good thing. We have a cone. It's dripping into a cylinder. All right? Look at what part A. Is part A dealing with the cone and the cylinder?
No,
Just the cone. What about part B? Here's the cone, here's the cylinder. I can't spell cylinder apparently. So part B is just dealing with the cone. What about part C? It's dealing with the cylinder. But it's, do you see what I mean? It's not that we're going to have to deal with all these things at one time. So let's start with part A. It says write an expression for the volume of water. So they want us to write an expression for volume of water in a conical tank as a function of h. Okay, look at the equation that they gave us. What is that in terms of? Y'all hang with me here. I got like 5 more minutes and we're done.
I am ready to come down.
Okay. What is the formula currently in terms of? H and R. What does our problem tell us it wants it in? Just H. So this R I need to replace. Now remember what we do in this kind of situation. We are going to set up a proportion. So watch what I'm going to do here. That though is dH over dt. That's the rate at which it's increasing. It's changing at a rate of that. So we're going to use that, but we can't use it for this part. Okay, so R over H equals, okay, well, what is the proportion? Is it 8 over 12?
No, 4.
It's 4 over 12. All right, and then we cross-multiplied, and we said 12R equals 4H. And right here, you have to decide, am I going to get R by itself, or am I going to get H by itself?
R.
I want to replace R, so I'm getting R by itself. So that becomes 4/12 H. You just got a point. Okay, and we haven't even done part A, but you get a point. Are y'all okay if I go ahead and say that this is 1/3 H instead of 4/12? Okay. So down here, all right, it says 1/3 pi. In place of R, I am going to put 1/3 H. And then I have the other H. So I've rewritten the formula, and now it is just in terms of H. Now I have 2 points.
Yay.
That's a lot better than 0. And I haven't even done Puigi. Okay? You don't need to simplify this equation, but we know we're probably going to have to use this equation, so let's simplify it. Okay, so watch this. 1/3 squared is 1/9. 1/9 times 1/3 is 1/27. Okay, and then h cubed. Okay, so this right here is going to be what I really use from now on, because it's going to be, especially if I have to take derivative. We didn't have to simplify, but if we derive it, it's a lot easier on us if it is simplified. Okay, so part B, it says, at what rate is the volume changing? Okay, so this is going to be my F, dV over dt. When, that's my W, H is 3. And let's think, what else were we given? Our equation is going to be from right up here, but what else have we been given about the cone? Right here. The depth h in feet of the water in the conical tank is changing at a rate of h minus 12. So dH over dt is h minus 12. Well, we just said that h is 3. Okay, so that's going to be 3 minus 12, or negative 9. So we had to do a little bit of calculation there. All right, now, to do this, I have to take derivative of my volume expression. So I'm going to go ahead and write dV over dt. And remember, we're using the simplified version, because it's going to be easier to derive. So 3 times 1/27. I'm going to write it as 3/27. You could write that as 1/9. Okay, pi h squared times dH over dt. So now we're up to 3 points. All right, dV over dt, that's what I'm looking for. So I'm going to rewrite 3/27 in place of h. I'm going to put 3. In place of dH over dt, I'm going to put negative 9. And you get a calculator on this problem, but you really actually don't need it. You could pretty easily figure out that this is negative 9 pi. Now, to get the fourth point here, you had to have the correct units. Like, the negative 9 pi is nothing without correct units. So, feet cubed So feet cubed would be good for volume, but we're doing the rate of change of volume per minute. So here's the deal. If you put negative 9 pi feet cubed, it doesn't even matter that you got negative 9 pi. You got to have the right units. Okay, so that's 4 points. And this is a tough problem.
Stop, give up.
Okay, now, I'm going to have you do part C on your own. It's a cylinder, and cylinders are actually easier to deal with. Okay? By the way, what's the rate of change of the radius in a cylinder? Okay, look at this. Here's the radius of that cylinder. As that cylinder fills up with water, how is R changing? It isn't changing. Okay? So what's dr over dt? 0. That's going to help you. Okay, here's another thing. If the water is coming out of the cone and it's dripping out, so it's negative, right? It's decreasing, negative 9 pi. What's the rate at which this one's filling up? Positive 9 pi. Okay, so like down here, and I'm going to call it dW, just so I can use a different letter than V, it's going to be positive 9 pi. Have